Now you have arrived at the big leagues of watershed delineation, and you've seen this picture before. It's the general explanation. We have a watershed where runoff converges to a single point, and then we have these subbasins that we might be interested in, also a focal point. But when we go to develop a project site, it has a different way of imagining how water hits it. And so I wanted to show you how we do that for a particular project site. Now, first of all, here we have our project boundary. It's this blue line, and it's not a point that we're dealing with, but a whole polygon that we're working with. So essentially there are points all along that polygon where water could intersect, and that we would need to know how much water is going to hit it so that we know what type of facility to put there, if we're going to allow it to run through the development, or we need to divert it around the development and so forth. So excuse me, the boundary itself can be any number of points that we need to work with. So that's the first point. The second point is you need to know, just like before, what is the general slope? As we identify the general slope, it's pretty easy to see that what we're really most interested are the northern and eastern boundaries of our project site, because the western and southern boundaries really don't have any. I mean, that's downstream, that's past our project. So any water that is going to intersect our project site is going to come from uphill moving downhill. And so we need to know, assuming that our boundary of our project is a number of points of interest, we need to know what amount of water is going to intersect there. Again, you want to trace the flow lines, but you want to trace every flow line that you see intersecting the project boundary. So here you have all the red lines that I'm showing as intersecting the project boundary. And then we've drawn these other ones, the orange ones, that do not intersect the project boundary. So we have some amount of flow that's going to miss our site. So again, we'll trace the red lines, start with those that intersect our project boundary. So I drew in here, there's one yellow line there, and another couple more ridge lines, and these aren't significant ridge lines, but they're ridge lines nonetheless. And they represent points along our project boundary that are local high points. In other words, if a drop of rain fell on that high point, it would be split along the boundary. And so where we have traced the intersection of the ridge lines and the project boundary, that's where we begin drawing our watershed boundaries. So we start where those two lines intersect. And so here I've drawn a little dot where one of those might begin. And I just go up the hill to a point where it looks like I've gone far enough. I'm not sure, but maybe it's a little bit further, and I draw the rest of the way up, and then now I go over to the other project boundaries for all the offsites and draw lines up perpendicular to the contours to try and find where all of the watershed areas drain to our project site. So for me, this is how I've envisioned this. This is what I see as the subbasins that impact our site. So with these off-site basins drawn, now it's time to draw what is happening on-site. So we're not only just interested in what is happening off-site, but we want to know the hydrology and the flow of water that is currently on our site. Because we're going to develop it, we're going to change things, we're going to redirect flow patterns, and all that stuff may happen in our development. So we need to be able to assess the current condition and compare it to that future condition. So let's look at the on-site basins for the current condition where nothing is there. So essentially, you just continue drawing the ridge lines through to get the different subbasins on site. So you can see now that I've got 4 on-site subbasins and 4 off-site subbasins. And that's because that's just how the water flows through the project site. So Next, it's always handy to label subbasins and also draw in flow arrows so that everybody can see and understand very easily the assumptions you made. And also drawing in flow arrows is kind of handy, if for nothing else, to validate the boundaries you have drawn. Sometimes when you start drawing in flow arrows, you realize, oh, you know, water really doesn't go that way now, does it? I just drew that line up a hill instead of down a hill, or whatever. You start to notice the mistakes a little better when you draw in the flow arrows. And that's really the gist of it. Now you're saying, well, why do we do this? What does this mean? Well, it means that for every one of these off-site subbasins that we have, these off 1, 2, 3, 4, we're going to have to, we want to calculate a flow rate for each one of those. And unless we change the topography, or, you know, we go in and grade it, or we create a channel, you know, or we create something that would divert this flow around the site, we're going to calculate Q for as many numbers of subbasins that are currently shown. So then you have to ask yourself, do we want water to go through our site? Do we want to divert it around it? And as you make that choice as to what impact your development's going to have, then that will change you'll redo this procedure for the proposed conditions. So this is fairly complicated. I'm not going to ask you to do this as an assignment, but this is much more the type of watershed delineation that you're going to be doing as an engineer in hydrology. So I felt like you needed to see it. So hopefully that is of some use, and goodbye.